Restore the Steppe, a novel approach to combating desertification, sequestering carbon, and promoting biodiversity. High is not one. CO Central Oregon is called a high desert for marketing purposes. Selling the cost Central Oregon Steppe to the Willamette Valley as a vacation, dry, sunny destination. The problem is the population thinks they live in some kind of actual desert, as prairie lands are mismanaged and degraded to the point of desertification. Manifest destiny is a powerful tool. Call an area a desert for long enough, it's going to turn into a desert. For the purpose of this publication, I will refer to the neglected landscapes full of juniper trees, sagebrush, rabbitbrush, and similar shrubs as the woodies. A woody plant is a plant that produces wood as its structural tissue and thus has a hard stem. In cold climates, woody plants further survive winter or dry season above ground, as opposed to herbaceous plants that die back to the ground until spring. Wet PT, when the settlers arrived in Central Oregon and started populating the region, the number of woodies was drastically lower than their current numbers. This was caused by the draining of wetlands, the destruction of herds, the elimination of wildfire, and ultimately overgrazing. The ecosystem that was in Central Oregon before the 1850s is nearly gone. Every drained wetland is full of woodies, increasing the number of woodies way past the natural balance. The woodies were mostly kept in check by wildfire, but intensive grazing and trampling also played a part. In my opinion, the woodies should be treated like invasives until their numbers are back to a historical level. The PNW, Pacific Northwest historical geology, is defined by floods. The first floods were of basalt lava when the PNW was in its volcanic stage. When the volcanic activity subsided, the glaciers took over. The Missoula floods raged over a 2,000-year period. Dozens of times the floodwaters tore through the landscape, partially ending up in a great prehistoric lake that was centered in alfalfa that radiated out for several hundred miles. During that 2,000-year period, about in the middle, another flood from the Great Salt Lake Bonneville Flats region slashed its way all the way to the alfalfa region. This history is antagonizing the issue of the area being called a high desert. Simple people see inland sand and immediately associate it with a desert environment. Well, the sand in CO says beach sand left over from the banks of the prehistoric lake. The fact there is a considerable amount of beach sand in CO says makes selling the region as a high desert very easy. Look, it must be some kind of desert. Look at all the sand. It's beach sand, though, totally different than desert sand. I had big plans to put in fruit trees, nut trees, separated by fields, to run chicken tractors through, and much, much more. At that time, I thought I was buying some sort of desert property. When it rained at least every couple weeks throughout the spring and summer of 2019, I started to suspect my property was not desert. My property was untouched, but had been a part of an area that was overgrazed by cattle for maybe 100 years. Lots of sage, some pretty big sage, juniper, and some grasses. I bought a full-size backhoe John Deere 310 SG when I bought my property to do all the earthwork. My backhoe has a bucket that opens into two parts, kind of like a mouth. I can open the bucket, slide it down over a 10-foot or less juniper, and pull them like a weed, roots and all. I cleared a full acre for the market garden not long after I moved onto the property. I pretty much removed 100% of everything from that acre. Around the same time, I was doing some work to my driveway to stop water from leaving my property, and a bunch of grass came in spots where I had applied a layer of dirt. Turns out the grass that came in was cheatgrass, an invasive species. I didn't know that at the time and was super encouraged by all the grass growing. I had a pile of dirt and rocks in the middle of the acre I had cleared for a market garden. I wanted to process the pile to get the rocks out, but that takes a special machine. So I just spread the dirt and rocks in a layer over the acre, making it all flat. I just picked the big rocks out by hand. I also threw down some grass seed I had collected in Bend that was being grown as ornamental grass. The variety gets quite tall in a landscape situation and is the biggest producer of fodder of all the 8 to 10 types of grass currently on the property. All that work resulted in an amazing flush of new growth. I was so encouraged by the growth, I came up with a plan to clear most of my property. I plucked 99% of the remaining juniper and floated the majority of the 10 acres. Floating is where you drive the backhoe backward with the bucket pressed down to the ground. The bucket follows the contour of the land, keeping whatever amount of pressure you set as you drive. What that did was kill most of the sage by either dragging it out by the roots or crushing it. There is a better way we will discuss in the solution chapter. After floating the majority of the property, I piled up all the woodies and burned them. I continue to burn the woodies by raking up the dead woodies, using the dead ones to help burn up the surviving woodies. This process has been more time-consuming than needed. With the correct equipment and techniques, there won't be much to clean up after the property has been restored. I had all the clearing done by winter 2021. That June, Oregon experienced an unprecedented heat dome. That pretty much stunted the growth of everything. Nothing seemed to be killed off, and I started to see a flush of new species the spring of 2022. That's when things started to get crazy. So many different types of grasses and wildflowers were coming in, it was shocking. That's when I discovered the area was no kind of desert, it's steppe. At that point, I'd recorded over 60 species of wildflowers and grasses that have just come back from seeds that were waiting for the proper conditions to return. When you look at even the properties right next to mine, you don't see anywhere close to the biodiversity. Seeds are amazing things. A quick story about seeds to illustrate their resilience. About 2,000 years ago, some meanies burned down some Jewish folks' date fields, rendering that cultivar of date extinct. About 10 to 15 years ago, a clay pot of those dates was found. The seeds were planted, and that cultivar of Judean date palm is back from extinction. Seeds are lying in wait. I've cracked the code on how to get them to come back en masse on the Central Oregon steppe. The steppe is very sick, and not much is being done. Some college research, some government research, and a charity nursery focusing on indigenous plants. There are no companies that restore prairie lands. A couple examples of the reality where CO is mentally on this subject. I approached a landscape company that also has a nursery and a classroom. Incidentally, their nursery is on drained wetlands, but they didn't want to even talk about these issues. They had no interest in anything related to prairie lands restoration. And when asked if they knew CO is steppe, not high desert, they looked at me like I was crazy. Not uncommon when simple people are given facts that counter their worldview. Then there is a charity, Oregon Natural Desert Association, ONDA, that is perpetuating the very damaging narrative that CO is some kind of desert, CO is steppe, period. It's not a high desert or a natural desert, and saying either one of those things is perpetuating a false narrative that is actually creating a real desert. Deserts are not what we need. We need wetlands, prairie lands, and biodiversity. As we continue down the road of man-made climate change by the burning of hydrocarbons, we need ways to sequester carbon fast. You quite literally cannot sequester carbon into forests for over 10 to 20 years once plated. Repairing grasslands will give you carbon sequestering within months if you have the seeds. Right now, the CO is a giant broken carbon sink. By fixing and maintaining COs, we will be curbing the effects of climate change. If the current path is not changed, a real desert is going to make another Dust Bowl situation. This process takes heavy equipment. The heavy equipment is doing something beyond the removal of the woodies. The machine's weight is mimicking a natural process that was stopped. Large herds of several types of herd animals used to trample the lands occasionally. What actually is happening, not sure. The compression of the land is necessary for some reason that needs further research. You also can't just burn it back to restored. When a degraded area is just burned, it leaves stumps and scorches the ground, because the woody fire is hotter than grass and flowers. Not to mention the fire does not do any of the work the herd animals were doing. It took over 100 years of mismanagement to get it this bad. It's going to take work to fix it. Start in the fall when the ground gets wet. Stop working when the weather is warm and dry. Seed during the rain in winter and early spring. There are 3 different procedures to restoring COAs depending on the condition of the land designated for restoration. The first type of land is bare land devoid of woodies, possibly covered in invasives like Russian thistle and cheatgrass. The second type is land with woodies. Type 3 is wildfire-ravaged land. Step 1 in the first example is burning the field. Next, hoof drum the entire property. There are aeration drums and spike drums. What is needed is a hoof drum. More simply, a cylinder drum. 2 solid cylinders, 6/8 spacing. This will mimic trampling, break up the crust layer, and create wells for seeds to get stuck in. That's all you have to do. If you can add seeding, you will accelerate the restoration process. The seeds I'd suggest are all the grass seeds you can find. Use drought grass, but also use every other type of grass you can source. Rice grass is highly recommended as it is a nitrogen fixer. Yarrow is also a nitrogen fixer. There are a couple of varieties of white yarrow indigenous to course. I see no issue in sowing all the colors of yarrow. Currently, there are no commercially available sources for restoration seed mixes. If your property has the woodies, the process is more involved. You'll need heavy equipment, a full-size backhoe or excavator, and also a smaller bobcat or tractor type of machine ideally. The goal is to pluck the woodies out, including the stumps. You definitely want to get those juniper root balls out of the ground. Leaving juniper stumps is a death sentence for the restoration of the ecosystem. Fix the hole left by the stump. When left, they create an unnatural habitat for several rodent species. When a wildfire eventually burns through an area with juniper stumps, the stumps can burn underground for weeks, possibly months. During my extensive test burning, I discovered the worst scenario is things burning for a long time. When burning the grass and wildflowers, the fire lasts seconds and doesn't get anywhere near as hot as a woodies fire. When the fire gets into the pile of juniper litter around the base of the juniper, the fire can last days or weeks. For the shrub woodies, a bobcat with a customized rock bucket would be ideal. Just cut the supports at the front of the edge of the bucket. That will open up the forks to let the shrub woodies slide in. Then just drive forward. The modified rock bucket catches the shrubs in its fork, and then you can pull them up by their roots. With the bobcat, clear paths to the juniper, so the backhoe doesn't have to run over any brush on its way to pluck the juniper. There is no juniper too big for a 300. Just dig around the base, cutting the roots, then just push it over. Once you have all the woodies plucked, harvest any juniper that could be used for woodworking, post making, or for firewood. With the remaining woodies, you can either let the stumps weather for a few seasons to remove the dirt and dry, or just not and just directly turn them into agricultural charcoal. Apply that agar right back onto the property. By following those directions, what you are doing is sequestering all that carbon back down into the land. Once you have the land cleared, if you can afford to seed, your results will be within months. Otherwise, it will take some years. I have not worked on wildfire burned land. What I think would work best for restoring those lands is plucking whatever woodies are left, hoof drumming, and seeding. Fire ant damage is a real issue that needs to be addressed to truly do a quality restoration. I've had success using a borax sugar solution. 1 part borax to 3 parts sugar. Add water, mix into syrup. This can be just put directly onto an ant hive, but that could kill other insects. I suggest putting the borax solution into something that restricts entry to ants. Concretional. When you arrive at a restoration project, assess a location for the agricultural charcoal pit. Not all land will have the ability to dig an agricultural charcoal pit. Using a mound technique in those situations is a solution. Once the restoration has reached what I call critical mass, which is when you have such dense coverage of beneficial species, the seeds can't blow away and the ground starts to develop a layer of litter. At that point, you can use the restored property as a seed producer. Typical seed production techniques are not going to work. work. Mow the resorted property, catch everything. Apply those catchings to seed the next property you'd like to restore. Think about the wind patterns when starting new seeding areas. The wind will do a much better job of sowing seeds than you can. Work with the wind for best results. If you are restoring huge areas, work with the wind to move the seeds through the landscape. Start upwind and work your way along with the wind. As an example, if you are restoring 50 acres, start on your upwind boundary, clear 10 acres, and seed if you have the budget or connection to a previously restored area. Wait a year, clear another section and repeat. Chapter 5. Sheep grazing and carbon sequestration. Introduction. Grazing animals, particularly sheep, have historically played a crucial role in maintaining grassland ecosystems. Their grazing behavior promotes plant growth, enhances soil health, and contributes to carbon sequestration. This chapter explores the role of sheep in restoring the Central Oregon steppe, focusing on how their wool and grazing activities contribute to carbon sequestration and ecosystem health. Sheep grazing and carbon sequestration. Sheep grazing can significantly enhance carbon sequestration in grassland ecosystems through several mechanisms: the growth of grasses and other plants, by removing older biomass and encouraging the production of new shoots. This process increases photosynthetic activity, leading to greater carbon uptake from the atmosphere. Soil organic matter. Sheep manure and urine contribute to soil organic matter, which enhances soil fertility and carbon storage. Over time, this organic matter decomposes and becomes integrated into the soil, sequestering carbon for decades or even centuries. Wool as a carbon sink. Sheep wool is composed primarily of keratin, a protein that contains carbon. Throughout a sheep's life, its wool continues to grow, effectively storing carbon. When wool is harvested and used in long-lasting products, e.g. clothing, insulation, the carbon remains sequestered for the lifespan of the product. Quantifying carbon sequestration. To grazing impact, studies have shown that well-managed grazing can increase soil carbon stocks by 0.5 metric tons of carbon per hectare annually. In the context of the Central Oregon steppe, this translates to significant carbon sequestration potential across large areas. Wool production. A single sheep produces approximately 2 to 4 kilograms of wool annually, which contains roughly 50% carbon by weight. This means that each sheep sequesters about 1 to 2 kilograms of carbon per year through wool production alone. When scaled to a flock of 100 sheep, this amounts to 100 to 200 kilograms of carbon sequestered annually. Case study: sheep grazing. On the Central Oregon steppe, in 2022, a pilot project was initiated to reintroduce sheep grazing to a restored section of the Central Oregon steppe. The project involved a flock of 50 sheep grazing on a 10-acre plot over a 6-month period. Key findings included sedation response. Grazing led to a 30% increase in grass biomass compared to ungrazed control areas. This increase was attributed to the stimulation of new growth and the suppression of invasive species. Soil carbon content increased by 0.8 metric tons per hectare over the grazing period, consistent with findings from other grassland restoration studies. Biodiversity. Grazing promoted the growth of native grasses and wildflowers, while suppressing invasive species like cheatgrass. Integration with restoration methodology. Sheep grazing can be integrated into the broader restoration methodology for the Central Oregon steppe in several ways. Sheep can be introduced to maintain the grassland and enhance carbon sequestration. Rotational grazing. Implementing a rotational grazing system ensures that grazing pressure is evenly distributed, preventing overgrazing and promoting plant recovery. Wool utilization. The wool produced by grazing sheep can be used in sustainable products, further enhancing the carbon sequestration benefits of the restoration project. Challenges and consideration. While sheep grazing offers numerous benefits, it must be carefully managed to avoid overgrazing and ecosystem degradation. Key considerations include challenges intended. Overgrazing can lead to soil erosion and the loss of native species. Grazing intensity should be adjusted based on vegetation recovery rates and soil conditions. Predator management. In areas with high predator populations, protective measures, guardian dogs, fencing may be necessary to ensure the safety of the flock. Economic viability.
The economic benefits of wool production and carbon credits can help offset the costs of restoration and grazing management. Conclusion: sheep grazing represents a powerful tool for enhancing carbon sequestration and promoting ecosystem health in the Central Oregon steppe. By integrating grazing into the restoration methodology, we can create a self-sustaining system that supports biodiversity, sequesters carbon, and provides economic benefits. This approach offers a scalable solution for restoring degraded grasslands worldwide, contributing to global efforts to combat climate change. Maintenance. Chapter 6: The natural process that maintained says, for 10,000 plus years worked just fine. But the herds are gone, and fences are everywhere. CEOs can be overgrazed very easily, destroying your work. Intensively grazing the land, in addition to burning every 3 to 5 years, is how to sequester the most carbon and develop healthy topsoil. Done correctly, millions of acres of good fodder can sustain livestock. I suggest actively going after any woodies that come back along with any other invasive species. As the species of wildflowers and grass start to come back, helping them spread by sowing their seeds around your property really works. If you don't intend to use animals to maintain the restored lands, you'll need to mow yearly. Conclusion: this study presents a novel methodology for restoring the Central Oregon steppe, demonstrating the potential for large-scale grassland restoration to combat desertification, promote biodiversity, and sequester carbon. The findings challenge the prevailing high desert narrative and offer a scalable solution for restoring degraded prairie lands globally. Further research and investment in grassland restoration are essential to address the ecological and climatic challenges of the 21st
century.